In this video, we are going to talk about the catalysis. Catalysis is basically a process uh, where a catalyst is actually used in order to alter the rate of reaction. So any reaction in which the catalyst is playing the role of changing the rate of reaction, either increasing or decreasing, we call those processes or those reactions as catalysis. So when we talk about the catalysis, we have two type of catalysis. The type of catalysis, we have homogeneous catalysis and we have heterogeneous catalysis. As the name itself is indicating, homogeneous means जो catalyst का जो phase होता है, जो state होता है, वो same होता है, it's matching with the reactant. And in the heterogeneous catalysis, the state of the catalyst being used is not the state of the reactant. Let's understand these two terminologies using different examples. When we talk about the homogeneous catalysis, here it's specified, it occurs when the catalyst is in the same phase or state as the reaction mixtures, as the reactant. For example, now I have taken an example that's basically you're an ester and esters are in the aqueous form. एक्वस फॉर्म में एस्टर है और वाटर भी लिक्विड फॉर्म है, तो इनका जो स्टेट है वो एक्वस या लिक्विड है, और उसके अंदर जो मैंने कैटलिस्ट, the catalyst which is being used over here is basically an acid. So acid and the reactant mixture, they are in the same phase, right? So this kind of reactions are known as homogeneous catalysis, are known, you're using homogeneous catalyst in these type of reactions. Proceeding further, we have the second category where we have heterogeneous catalysis. Now, in the heterogeneous catalysis, the catalyst state or phase is not matching with the reactant phase. The reactant is hydrogen peroxide, and the hydrogen peroxide, this is H2O2. We are having H2O2 here. So the H2O2 is basically, this is hydrogen peroxide, and we are using manganese oxide. The manganese oxide is the solid form, solid state, whereas the hydrogen peroxide, we have H2O2, is in the aqueous form. So their state is not matching. So when such reactions take place where the catalyst is not in the same state, we call it heterogeneous catalysis. Now moving ahead, let's do some few more example of homogeneous catalysis. Now in this particular example, we'll be seeing another example of homogeneous catalyst. Now in this example, let me tell you first thing that on what grounds the homogeneous catalyst act. The homogeneous catalyst जो भी होते हैं उनका ऑक्सीडेशन स्टेट जो होता है वो ड्यूरिंग द रिएक्शन चेंज हो रहा होता है. जैसे फॉर एग्जांपल iron, we have in many cases, like we have seen the iron, we are taking iron 2 plus, and during the process or during the reaction it will change into iron 3, right? Similarly, so that is the reason that the transition metals are considered as the best of the catalyst, because their oxidation state can easily change. Now, in this particular example, we are looking at the decomposition of hydrogen peroxide. Hydrogen peroxide is H2O2. And this hydrogen peroxide is being decomposed in the presence of iodide ions. The iodide ions, their oxidation state or their charge is negative. And the iodide ions are actually going to be oxidized to iodate ions. If we talk about the oxidation number, then iodine oxidation number will be +1. How? O IO negative, overall charge of this ion is basically, let's take iodine as X. This is going to be -2 equals to -1. So X is going to be +1. So iodate में iodine का oxidation number जो है वो +1 है. So it's changing from -1 to +1. So we'll say that this has been oxidized. This has been oxidized to iodate ions where its oxidation number is +1. Then these iodate ions, they will again get reduced. They will get reduced to your iodide ions again back. And during the process, what is happening? This catalyst which is iodide ion, is helping in decomposition of hydrogen peroxide into water and oxygen. And the overall equation is going to be this: H2O2 in the presence of a catalyst, that is iodide ions, is going to decompose into H2O plus O2. So here what is happening, the ions, the iodide ions is basically is changing its oxidation state from -1 to +1, and this particular process is helping in the decomposition of the reaction. The second example of homogeneous catalysis we have here of iodine peroxodisulfate sulfate reactions. Okay, so what happens here? The peroxodisulfate, which is also known as persulfate ions, they oxidizes iodide ions to iodine. Now, this reaction is considered to be very slow. The reason is that both the ions, your persulfate ions and your iodide ions, they both are negatively charged. सो नेगेटिव चार्ज होने की वजह से ये आपस में रिपेल करते हैं, दे देयर इज अ लॉट ऑफ रिपल्शन बिटवीन देम. सो यहाँ पर इनको एक्सट्रीमली हाई अमाउंट ऑफ एनर्जी चाहिए इन ऑर्डर टू रिएक्ट. सो व्हाट हैपेंस हियर, वी यूज अ कैटलिस्ट ओवर हियर. इन दिस वी यूज द कैटलिस्ट व्हिच इज बेसिकली आयरन 3 आयंस. ठीक है, तो आयरन 3 आयंस जो होंगे वो कैटलाइज करेंगे इस रिएक्शन को. सो व्हाट हैपेंस, दिस रिएक्शन टेक प्लेस इन टू स्टेप्स. द स्टेप 1, either iodide or your persulfate, any one of the reactants, we make it react with the iron ions. If iodide we are taking, we make it react with the iron 3. So what happens, the iron 3 get reduced to iron 2 and iodide changes into iodine. Then what happens, side by side, the iron 2 which has been formed, it is going to again going to get oxidized, और वो oxidizing agent के तौर पे पर it's going. So iron 2 as a reducing agent is going to reduce your persulfate ions back into sulfate. So basically the catalyst iron 2 or iron 3, which is facilitating the iodide and persulfate ions or peroxodisulfate ions to react together. So iron 2 and iron 3 are basically the catalyst, and they are in the same state as you have the reactants. So your iron 2 and iron 3, they are again in the aqueous form. So this is how the catalyst, it facilitate the reaction. It makes the two same charge ions to react together to give you sulfate and iodine. Now this reaction can also be represented in the form of energy profile diagram. Now in this energy profile diagram, we see there is one red hump, big hump. This reaction is in the presence of uncatalyzed reaction. Now, this big hump is basically where the large amount of energy is needed in order to make this persulfate and iodide to react together. But if the same reaction is made to happen in the presence of a catalyst, then we see this taking place more smoothly. And the black one, the black where you can see the two humps, is basically the catalyzed reaction. Now we have this reaction split up into two steps. The first step, what happens here, the iron 3 is being reduced to iron 2. The first reaction take place where the iodide changes into iodine, and the second reaction where the iron 2 changes into iron 3, where your persulfate changing into sulfate ions. So the two-step reaction is shown by the two humps where the catalyst, different catalysts are basically catalyzing the different part of the reaction, and in the end we are getting the product, that is sulfate and iodine. So this is how this particular reaction can be depicted in a form of energy profile diagram, right? So Acha, one more thing which is associated with these kind of a reaction, they ask you many a times that how do you decide what catalyst is going to be the most feasible in this in any kind of a reaction. तो ये चीज जो है हम ई नॉट वैल्यू से भी प्रिडिक्ट कर सकते हैं. अगर आपके पास जो आपके जो रिएक्टेंट्स हैं, लेट्स से हमारे पास दो रिएक्टेंट्स थे, एक पर ऑक्सोडाइज सल्फेट रिएक्टेंट था और दूसरा हमारे पास आयोडाइड एज अ रिएक्टेंट. अब peroxodisulfate when it converts into sulfate ions, तो इसकी जो E naught value है वो, और हाउ द आयोडाइड कन्वर्ट्स इनटू आयोडीन, उसकी ई नॉट वैल्यू या इलेक्ट्रोड पोटेंशियल, इन दोनों की जो वैल्यूज है, इन दोनों की वैल्यूज के बीच की जो वैल्यू होगी, जिस मेटल की भी होगी, जिस ट्रांजिशन मेटल की भी होगी, तो वो इज दैट पर्टिकुलर मेटल इज गोइंग टू बी द मोस्ट feasible, most suitable for the as a catalyst for this reaction. Now, for example, the E naught value for the peroxodisulfate to convert into sulfate is positive 2.01, whereas for the iodine converting into iodide is positive 0.54. So the iron 3 converting into iron 2 ki jo E naught value is 0.77, and that lies between this range. So iron 3 or iron 2 are said to be the best or the feasible catalyst for this particular reaction. Now, the third example, the third case which is given in our syllabus is basically of the oxides of nitrogen and the acid rain. So, what happens here? The sulfur dioxide, which is produced by the burning of the fossil fuel, right? The sulfur content in the fossil fuel that burns in the presence of oxygen and sulfur dioxide is produced. Now, this sulfur dioxide, which has been produced, do not easily converts into sulfur trioxide, which is again an acidic oxide. So, it require a facilitation, another step. Sulfur dioxide then react with the atmospheric nitrogen 4 oxide to convert into sulfur trioxide, and it gives nitrogen monoxide. ठीक है, या तो हम इंडस्ट्रीज में सल्फर डाइऑक्साइड को, विच वी हैव स्टडीड इन ओ लेवल्स के कॉन्टैक्ट प्रोसेस के थ्रू, कि आप इसको हाई प्रेशर एंड हाई टेम्परेचर पे सल्फर डाइऑक्साइड इज मेड टू रिएक्ट विद द एटमॉस्फेरिक ऑक्सीजन. Naturally, in atmosphere, this reaction is not possible because that much high temperature and pressure is not basically cannot be given. So basically the catalyst is being used here. The nitrogen 4 oxide will be used here, which is going to catalyze sulfur dioxide to convert into sulfur trioxide. Sulfur's oxidation number is +4, and here sulfur trioxide means sulfur oxidation number is +6. So the sulfur dioxide get oxidized to sulfur trioxide and you get nitrogen monoxide. This nitrogen monoxide later on, after combining with the oxygen from the air, converts back into nitrogen 4 oxide. So we can see that the catalyst remains unused and nitrogen NO2 remains NO2, even though the oxidation of sulfur dioxide take place and the sulfur trioxide is being formed. So this is the third example which is in our syllabus. Now let's move on to an exercise just to practice the concept what we have studied right now. Okay, let's do the question. And the question states that, state which pair of the substance 1 to 4 below might catalyze a reaction. As I said in the previous example, I've explained कि जो हम catalyst choose करते हैं, जो transition metal choose करते हैं, वो जो आपके reactants की जो E naught value है, उसके दरमियान का, उसके बीच का आप metal choose करते हैं, जिसका E naught value is in between. Now I have the values written down here. When we have when I have peroxodisulfate ion and it is converting into sulfate ion, so E naught value is positive 2.0. And iodide, when it is converting, तो iodide की जो E naught value है, that's 0.54. Fine. When the iodine is converting into an iodide, the E naught value is 0.54. Now they're asking you, these are different options given to you. Option 1, where the nickel ions, nickel ion की जो E naught value है, वो है nickel की E naught value is 0.25. For manganese, it's positive 1.49. और सेरियम की पॉजिटिव 1.70, कॉपर इज पॉजिटिव 0.15. So ये different values हैं. आप बताइए, you tell me, you suggest which is going to be the most suitable, which is going to be the most suitable metal which can be taken up as a catalyst in this scenario. So what I explained before कि इन दोनों E naught value के बीच की जो E naught value जिस metal की भी होगी, that is going to be the most suitable. So let's see which is going to have in between values. So this is definitely, it's below, this is in between, this is in between, and this is again a below. So basically the manganese can be used as a metal, and same goes the cerium can be used as a metal, which can act as a wonderful catalyst because ये E naught values जो हैं, ये इन दोनों reactant की E naught values के बीच में है. So जिस catalyst, जिस मेटल की वैल्यूज बीच में होंगी, that can act as a wonderful catalyst. Apart from this, there is another question: describe in terms of oxidation number change which species are being oxidized and which has been reduced in these equations. I'm sure you can do it on the basis of oxidation. So take a snapshot and please kindly attempt the question. This is a solution for the question which I have just shown. As we have taken few examples, 3 examples of the homogeneous catalysis, and I've explained you that the homogeneous catalysis is basically, it involves a change in the oxidation number of the ions which are involved in the catalysis, right? So we have taken the first example of iodine peroxodisulfate where iron 2 and iron 3 was taken. Then we have taken the example of the oxides of nitrogen when the acid rain take place. There we have seen this the nitrogen 4 oxide, it converted into nitrogen monoxide. There the oxidation number was changing. And one more example we have done, that was hydrogen peroxide combining with hydrogen peroxide, which was which was reacting with the iodine. So it was first changing into that was first changing into iodate, and then later on the iodate was changing back into iodide. So these were the 3 examples which were there in the syllabus. Now let's move on to the next category of catalysis, or the type of catalysis which is known as heterogeneous catalysis. Now in the case of heterogeneous catalysis, the mode of action is basically, the mode of action we say that is basically adsorption. We say it's adsorption. So what is the word adsorption? Adsorption means that, adsorption is a word means कि जो आपका जो कैटल अब यहाँ पर जो कैटलिस्ट और द रिएक्टेंट्स होते हैं, इनका फेज या इनका स्टेट जो होता है वो डिफरेंट होता है. द स्टेट ऑफ द कैटलिस्ट एंड द स्टेट ऑफ द रिएजेंट्स, दैट्स टोटली डिफरेंट. ठीक है, तो इसमें क्या होता है, जो रिएजेंट्स जो होते हैं, मेजॉरिटी ऑफ द सिनेरियो में जो कैटलिस्ट हम यूज करते हैं, वो कैटलिस्ट इज बेसिकली यूज एज इज taken as a solid, is taken in the solid state. For example, let's consider a few examples here, the very common ones, like for example in the case of Haber process. In the case of Haber process, we were taking nitrogen and we were taking hydrogen, and they were forming basically ammonia. Okay, and the reactant we were the catalyst we were taking, that was the iron, which was taken in the solid form, whereas the rest of the reagents, they were in the gaseous form. Okay, इसी तरह से sulfur dioxide when combined with oxygen, this was a contact process, so we were getting sulfur dioxide and sulfur trioxide, and the catalyst we were using was vanadium pentoxide. So these are very common examples which we have been studying for the past 2 years in O levels and A levels. Again, we have studied in AS. Now, whenever we have a heterogeneous catalyst, the catalysts are basically, majority of the cases में ये solid होते हैं. ठीक है, they are basically solid. तो सॉलिड्स के ऊपर जो आपका रिएक्टेंट होता है वो पहले तो डिफ्यूज होता है, इट गेट डिफ्यूज ऑन द सरफेस. ठीक है, आपके पास जो भी रिएक्टेंट है, लेट्स से टेक द एग्जांपल ऑफ अमोनिया मैन्युफैक्चरिंग ओनली. सो वी हैव द हाइड्रोजन एंड वी हैव द नाइट्रोजन. So both the reactants, they will get diffused. After getting diffused, they'll get adsorbed. Adsorb means they will be bonded only on the surface. Adsorption is very different from absorption. Adsorb is a different terminology and absorb is a different terminology. Adsorb means bonding only on the surface, bonding only on the surface. When you talk about the absorption, absorption is like the sponge has absorbed the water. Deep inside, the water has been absorbed, but the adsorption only take place on the surface. So after the diffusion take place, so what happens here? The adsorption will be on the surface, and this bonding or this adsorption is nothing but the bonding. So when this adsorption take place, what happens? The इनके जो bonds होते हैं खुद के, नाइट्रोजन के हाइड्रोजन हाइड्रोजन बॉन्ड या नाइट्रोजन ट्रिपल बॉन्ड नाइट्रोजन, these bonds they get weaken up. ये bonds weaken up हो जाते हैं, और ये जो है इनके जो bonds with the surface that strengthen up, और इसकी वजह से जो इनके जो अपने जो bonds होते हैं वो weaken up होने के बाद slowly and gradually they breaks down. ठीक है, दे ब्रेक्स डाउन, एंड बिकॉज दे ब्रेक डाउन, तो अब ये क्या हो गए, दे आर देयर इन द एलिमेंटल फॉर्म, ये अपने एलिमेंटल फॉर्म में आ जाते हैं। उसके बाद द नेक्स्ट स्टेप इज व्हेन दे आर इन द एलिमेंटल फॉर्म, नाउ द न्यू बॉन्ड स्टार्ट फॉर्मिंग, दे स्टार्ट रीअरेंजिंग देमसेल्फ, ये अरेंज रीअरेंज करते हैं, और न्यू form may they start bonding themselves. As soon as a new molecule is being formed, is being bonded, a new bond is being formed, now what happens, the diffusion take place from the surface, again the diffuses from the surface. So catalyst act as a the catalyst actually act as a surface on which the adsorption take place, जिसके ऊपर adsorption होती है, और इस एब्जॉर्प्शन की वजह से जो मॉलिक्यूल के जो खुद के जो बॉन्ड्स होते हैं, वो बॉन्ड्स जो होते हैं वो वीकन अप हो जाते हैं, और जब ये मॉलिक्यूल के जो बॉन्ड्स वीकन अप होंगे, तो फिर इनके अंदर रीअरेंजमेंट ऑफ अ न्यू मॉलिक्यूल विल टेक प्लेस, एंड देन व्हाट हैपन, द डिसॉर्प्शन विल टेक प्लेस. सो दिस इज हाउ, सो होमोजेनस catalysis based on the change in oxidation number. ठीक है, वो किसके ऊपर बेस करती है, ऑक्सीडेशन नंबर चेंज, इट इन्वॉल्व्स ऑक्सीडेशन नंबर चेंज of the ions of the catalyst which is being involved. Whereas the heterogeneous catalysis, it involves the we normally have the solid as a catalyst which act as a surface, जो surface के तौर पे, जो एक background के तौर पे provide करते हैं, जहां पर आके आपके molecules जो होते हैं वो absorb हो जाते हैं, और जब ये absorb होंगे, तो इनके बीच का बॉन्ड ऑन एब्जॉर्प्शन स्ट्रांग हो जाएगा, और उनके अपने जो बॉन्ड्स होते हैं वो वीकन अप हो जाएंगे, वो वीकन अप जब होंगे, तो वो ब्रेक डाउन हो जाएंगे, और जब वो ब्रेक डाउन होंगे, तो फिर वहां पर रीअरेंजमेंट ऑफ न्यू मॉलिक्यूल विल टेक प्लेस, एंड वंस द रीअरेंजमेंट ऑफ द न्यू मॉलिक्यूल्स टेक प्लेस, नाउ द दे diffuse out, or deabsorption will take place, and a new molecule will be formed, right? So this is how the what you call it, this is how your heterogeneous catalyst they act. So we have an example of ammonia formation here, we have an example of what do you call it, uh, the other example we have here is of just a minute. The other example we have is of the catalytic car converter. We have a transition element in the catalytic car converter. In the catalytic car converter, we have the catalyst which has a जो कि आपका honeycomb structure inside the catalytic converter, जिसके अंदर आपके catalyst होता है honeycomb form में, जहाँ पर different oxides of nitrogen, the nitrogen oxides and carbon monoxide, they come and absorb on the surface of this catalytic honeycomb structure, और वहाँ पर वो फिर उनके bonds weaken up होते हैं, और rearrangement of the atoms take place once the bonds break up and a new molecule form, and then desorption take place, and the gas, the newly formed molecules, they basically they diffuse out. So these are the two examples of the ammonia formation and of the catalytic car converter के ये दो examples हैं जो आपके syllabus में है, ठीक है? So with this we finish off with the catalysis. This is the question, and the question says, describe in the general term what is meant by desorption. Nickel act as a catalyst for the hydrogenation of alkene, for example here. So nickel is acting as it's in the solid phase, whereas the alkenes and hydrogen, they both are gases. So here suggest how nickel catalyzes this reaction, referring to the steps of adsorption, reaction on the metal surface, and desorption. So what we have studied here, so those are basically the steps which we can write down. ठीक है, ये जो steps हमने पढ़े हैं अभी इस scenario में, यही steps जो हैं, diffusion on the surface, adsorption, reactions, breaking of the bond, desorption and diffusion away. So यही steps आप detail में इस scenario में भी लिखेंगे, ठीक है? Now in the car catalytic converter, rhodium catalyzes the reduction of nitrogen 2 oxide to nitrogen. Draw a diagram to suggest how nitrogen monoxide is absorbed on the surface and how nitrogen is formed. Again, similarly, diagrammatically, you will be explaining it. Draw the diagram, and side by side you can explain it, right? So you can, this is the marking scheme for this particular question. Have a snapshot and you can check your answers. This is the question, take a snapshot. And this is the marking scheme for the question which I've just shown you before. These are some more questions for the practice. Marking scheme of that question. Marking scheme of the previous question. That's all for the catalysis.